The exact amount of oxygen present at the moment Earth's core formed was decisive for two essential elements for life, phosphorus and nitrogen, to remain accessible in the mantle and crust. This is the conclusion of a new study published in the journal Nature Astronomy. According to researchers, without this precise balance, a rocky planet might appear to have favorable surface conditions, but it wouldn't meet the chemical requirements necessary for biological processes to emerge. During the formation of planets, the starting material is composed of molten rock. In this process, heavy metals like iron sink and form the core, while lighter materials remain in the outer layers. The amount of oxygen available during this phase directly influences the fate of other chemical elements. The study points out that oxygen needs to be within a very narrow range for phosphorus and nitrogen to remain in sufficient quantities in the mantle and crust. With too little oxygen, phosphorus binds to iron and is dragged into the core, becoming unavailable for biological processes such as the formation of DNA, RNA, and cellular metabolism. On the other hand, an excess of oxygen favors the loss of nitrogen to space. Models also indicate that other planets like Mars fell outside this ideal range. In the Martian case, calculations show a higher presence of phosphorus in the mantle than on Earth, but less nitrogen, which creates unfavorable conditions for life as we know it. These findings suggest that the traditional emphasis on the so-called habitable zone, based on the presence of liquid water, may be insufficient. This is because even if a planet is at the right distance from its star and has water, it might not possess the chemical conditions to sustain life. For the researchers, this makes the search for life on other planets much more specific. According to them, we should look for solar systems with stars that resemble our Sun.